Hi! I have bought a pack of flicker flame candlelight bulbs to play with. Hopefully they are better than the faulty one I already have, despite their low price and questionable packaging. I will test how well they work, or not, even when dialed down on a light dimmer, or when dialed up a lot to 3000 volts, 13 times more than they are designed for. And with a total of 9 of them, I might finally be able to measure how many watts these allegedly 3 watts light bulbs actually draw. Let's find out. Don't play with high voltage unless you know the rules of that game. My first flicker flame bulb does not have a convincing flame effect. Since they forgot to bend the tips apart, it only lights up at the top and flickers downwards, opposite of a real flame in gravity. But with a new pack of 8 pieces from another brand, I hope at least one of them has a nice flickering and rising flame effect. On the package, it does look like the tips are spaced farther apart than the bottom end. Good sign. But the package also says bayonet cap, even though they should be screw cap. So let's see how well these ever ready bulbs work. First one out is a screw cap as ordered. Great. Are the tips bent apart? Oh, the 2 plate electrodes are quite far apart and increasing in distance all the way up. Not just at the tips like the classic design. And they are not well aligned. There's clearly an overlap and an angle mismatch. Will this huge plate distance even work at only 220 volts in my house? Oh no. This surface does not emit light. The plate lights up on the inside, between the plates. A one-sided bulb. Quite weird how this follows Paschen's law I explained in the earlier video. But hold on. After warming up, it actually works alright. Both plates are mostly lighting up on their outside, at the bottom part, and flickering upwards, though the plasma never reaches the tips that are too far apart for a conducting ionized path at this voltage. Well, still better than I thought from seeing the sloppy assembly. A bigger surprise is how plasma forms even when the lamp is turned off, but still plugged in. Must be really easy to ionize if induction in the power cord is enough. Okay, interesting start. Is the next one better? Yes, this looks promising. More reasonable spacing, tip separation and alignment. This one is alright, right from the cold start. Though the plasma is all over the place, even on the lead wire. Let's quickly go through the rest. Number 3 is even worse than number 1. A lot of plasma only between the plates, showing exactly what I thought would happen with very close plates until understanding Paschen's law. The optimal condition for the discharge is not at the lowest pressure or at the shortest distance. After warming up, it slightly improves on one plate. Worst one yet. Number 4 looks a lot like number 2, but has too much action on the inside between the plates, even when warm. In number 5, the plates are mounted crooked, with too little plasma on the plate which outside faces mostly down. Number 6 looked promisingly built, but it is very bottom focused with no tip action. Number 7 starts with some unusual side-to-side flicker, but ends up with decent coverage, though mostly between the plates at the upper tip. Number 8 is again one of the widely spaced. But after warming up, it is the craziest to look at. Not really a flame imitation, but extraordinary coverage and patterns. Looks great, filmed at 1000 frames per second too. More info about why the plasma moves like this in my earlier video. Now, these lamps are always marked 3 watts, but my first one seems to only sip energy, less than what my power meter will display. With 9 lamps running at the same time, it is more likely that I can find what one of them draws in average. If you have followed my channel, you know I have an extensive collection of light bulbs. My patrons have even seen some crazy ones I haven't made a YouTube video about yet. However, finding 9 portable lamp fittings in my home was a challenge. Through some questionable choices and an E27 to E14 conversion, here we are. Reminds me of something out of a funny Christmas movie. Hey, not bad. These bulbs do look better in larger numbers. But how many watts are they drawing? 27? No, at 217 volts it is only 9.5 watts. Just 1 watt per bulb. A third of the rating. At 220 volts it increases to 10 watts, 1.1 watts per bulb. Okay, they do like higher voltage, but I still find it unlikely they will draw 3 watts each at 230 volts. This makes me wonder how a flicker flame bulb will react in a light dimmer. I tried measuring how low the effective voltage from the dimmer will go, but I didn't see any major voltage drop. The dimmer may need a load to work properly. Ah well, let's see how bulb number 8 reacts to a lower voltage in the dimmer. Nice! At very low voltage, the flicker looks more like a spark or lightning. Thin streamers that fatten up when fed more watts. Here's how it looks at 1000 frames per second at lowest power on the dimmer. Beautiful science going on here. What if we instead increase the voltage a lot? We will try after a short message. A big thanks to all my patrons. I appreciate your help with keeping these videos like this one coming. For just $1 a month, you can help me out too and get full access to all my posts on patreon.com. Link in the description. Thank you. My patrons have already seen this lamp tester. It delivers 3000 volts at 280,000 Hz, but only in microamps, so very little wattage. Again, I am using bulb number 8, my new favorite flicker lamp. Wow, lots of plasma despite the very low wattage. We can also tell which plate is connected to the screw cap or foot contact. If I short the 2 contact points by wrapping some alufoil around them, I should be able to light up both plates at the same time. I used too little foil. Let me tighten it up. No, only one plate will light up. I may temporarily have forgotten that there is a current limiting resistor inside the screw base. The resistor is in series with only one of the plates. So with this one-pole power supply, the plate without the resistor gets more or all of the current. Okay, now we know the resistor is in series with the plate electrode attached to the foot contact. Good design choice since the foot contact is live, while the screw thread is neutral, if the light bulb socket is up to code. The lamp tester shows that high voltage is important, perhaps more than high wattage, for these bulbs. Though 3000 volts is too much, notice how the neon gas near the glass is also ionized to a plasma, especially when I touch the glass and capacitively coupled to the electric field, like in a plasma ball. I can feel how the plasma heats up the glass fast. I am not sure how well this glass handles uneven heating, so I will keep the test run short and give the glass time to cool down. And don't wear a ring while doing this, as I have demonstrated earlier using a plasma ball, before you go watch me get zapped in that video. Hope you enjoyed this video enough to click like and perhaps subscribe for more like it. In any case, thanks for watching. Bye for now.